Let's talk about ocean acidification. Sounds pretty horrible, right? Yep, it is. But why? Now, I think that the word acid can conjure up mental images of things like aliens spraying green corrosive goo all over the place, melting a hole straight to the center of the earth. Well, is that what's happening to our beautiful oceans? Not quite, but as a direct effect of human activity, the chemistry of the oceans has changed dramatically over the last century and ceased to threaten the wealth of natural beauty and ecological value below the water's surface. First things first, an acid is simply a compound that breaks apart in water to form hydrogen ions. A simple one would be hydrochloric acid, also known as stomach acid. On the flip side, a base breaks apart to form vulnerable OH- groups. The free-floating hydrogen is super aggressive and is looking for something to attack. Once it finds a free-floating OH- group from a dissolved base, it says, "Hey, that looks like an easy target, sayonara, bubba," and reacts. When you get heartburn, it's usually because you have an excess amount of hydrogen chloride in your stomach. Popping a couple of antacids will help, because they're made of weak bases and neutralize the high acidity. So how does this translate to the ocean? Well, thanks to pollution, there's an excessive amount of carbon dioxide in the atmosphere, which dissolves into seawater. Carbon dioxide reacts with water to form carbonic acid. Seawater is naturally saturated with another base, carbonate ion, that acts like an antacid to neutralize the H+, forming more bicarbonate. The net reaction looks like this. Carbon dioxide readily dissolves into water, and since the ocean has such a high surface area, a lot of acid can be produced. Just how much? Well, since the beginning of the Industrial Revolution, the ocean's surface water pH has fallen by 0.1. The pH scale is logarithmic, so in other words, this change represents a 30% increase in acidity, which will only get higher and higher, with NOAA projecting that by the end of this century, the ocean could be nearly 150% more acidic. Yikes. So now you're thinking, okay Colin, you tricked me into watching you draw some chemicals on a whiteboard. Where are you going with this? Well, it all comes together, okay? Many invertebrate sea creatures like coral, clams, certain plankton, mussels, and sea urchins rely on carbonate ions to form their shells. With a low concentration of carbonate in the water, these animals cannot build their homes and die. So many of these animals form a vital basis for their ecosystem, like coral providing an intricate structure for thousands of species to survive, or tiny planktonic sea butterflies serving as the basis of a food web. Basically, this can all be hard to swallow. And though it may be too late to save beautiful places like coral reefs, we can still do something. By being responsible now, we're trying to create a habitable planet for our own grandchildren. So don't be shellfish. Save the Earth.